Hi everyone, today I'll be walking you through my Physics 2 charged tape lab. The goal of this experiment is to explore how charged objects interact and to see Coulomb's law in action with something as simple as pieces of tape. The main equation we used is Coulomb's law, which is kq1q2 over r squared. And we also used the electric field equation, which is kq over r squared, r hat. And we also balance it with gravity, which is Fg equals mg, or F sub g equals mg. This allows us to calculate the charge needed for two tapes to repel each other and reach equilibrium. Here you can see the pictures I took during the lab. In these shots, I'm basically holding just a strip of tape near another strip that's been charged. And by pulling the tape from the surface, both strips gain the same type of charge, so they repelled each other. You can basically just see how I'm carefully holding the tape so I can measure how far it displaces when it's repelled by the other. And yeah, as you can see, it's the tape on top has been pushed up compared to the first time. This just shows the real life effect of electric force, and yeah, just two very light objects moving apart simply because of their charge. On paper, I worked out the relationship between the electric force pushing the tapes apart and the gravitational force pulling them down. At equilibrium, Fe equals Fg times tan theta. Fe is the electric force of repulsion, G equals mg is the tape's weight, and theta is the angle the tape makes when it's displaced. From this, I derived the required charge on tape, which is Q equals root mgd squared over K. Where d is the displacement, this calculation shows that even a very small charge can balance out the tape's weight and create a visible separation. In the pictures, that's exactly what I was observing, the repulsion between the two charged tapes. Finally, this program defines two tapes as spheres and calculates the charge required for equilibrium. It computes the electric and gravitational force, shows the force arrows on tape 2, orange for electric, blue for gravity, and it plots electric field vectors. So that's the cyan colored one around tape 1. So we can visualize how the field extends in space. And to conclude, in this lab, we connected theory, experiment, and simulation. The tape experiment showed repulsion firsthand. The paper calculations proved how small charges can create measurable displacements, and the glow script simulation tied it together with the force vectors and electric fields. This lab basically gave me a better understanding of Coulomb's law, electric fields, and how physics equations applies to real-life experiments. Thank you.